Hello class, this is a video tutorial on the properties of quadrilaterals. A quadrilateral is any shape that has four sides and four angles. This example that I've shown here is considered an irregular quadrilateral as there are no noticeable patterns or features. So long as there are four sides, so 1, 2, 3, and 4, and there are four angles, 1, 2, 3, 4, it is considered a quadrilateral even if it doesn't look too fancy or anything nice about it. There are, however, special named quadrilaterals, and they are determined by these three criteria: the number of pairs of parallel sides, the number of pairs of sides of equal length, as well as whether the pairs of equal sides are opposite or adjacent. And I promise we'll go through a lot of examples of these just to show you what this might look like, and the number of right angles in the quadrilateral. Now, from just these three criteria, we can accurately define special quadrilaterals. There are also particular angle relationships in some of these quadrilaterals, but these special angle relationships, these don't define the shape. These three criteria do. All right, so without going any further, let's take a look. So we have the name of the quadrilateral, just one example of what it might look like, and what properties it might have. So the first one we've already seen is an irregular quadrilateral. So here's an irregular quadrilateral. There's four sides. That's pretty much it. There's nothing special about it. The first special quadrilateral we can think of is a trapezium. And the property of this is that there is just one pair of parallel edges or parallel sides. Take a look. So here is one pair of parallel sides. That's pretty much it. The other sides, they don't have to be equal, so long as it joins from here to here and from here to here. So it might actually be even shorter. You might actually make it like this. Still a trapezium. Might make it long like this. Still a trapezium, so long as there is exactly one pair of parallel edges. The next one is called a parallelogram. This has two pairs of equal, opposite, parallel edges. Now that might be a little bit of a mouthful, but let's take a look. This edge and this edge, or these sides, they are parallel. But on top of that, they are also equal in length, but they are opposite, meaning they are equal, but they are far apart from each other. So these are one pair, so that's one pair of equal opposite parallel sides or edges. And here's the second pair. So these two sides are also parallel, but they are also equal in length. But once again, they are far apart from each other, so they are equal, opposite, parallel edges. Now, within parallelograms is the first case that we have a special angle relationship, and I've marked it here with a dot and an X. So whatever angle this might be, this angle must be exactly the same. And likewise, whatever angle this might be, this angle must also be the same. So for example, if this is 72, this angle here must also be 72, or whatever the size might be. So that is a parallelogram. The next special quadrilateral is called a diamond, or you might call it a kite. They have two pairs of equal adjacent edges. Notice how this one is equal opposite, meaning these two sides are the same length, but they are opposite from each other. But now in a diamond, these two sides are equal, but they are side by side. They are touching at one point. So these have to be equal adjacent edges. There are two of them. Here's one pair, and here's another pair. So there are two pairs of equal adjacent edges. And this also has a special angle relationship in that these two particular angles, they are equal to one another. Okay, let's keep going. A rhombus. So a rhombus, just to really summarize it, it's just a parallelogram with four equal edges. So in a parallelogram, these two edges are equal, and these two edges are equal. But these edges are not equal to each other. A rhombus, they are just all equal to each other. So a rhombus, you can actually say it is still a parallelogram. It's just that a rhombus is a special parallelogram. So this actually has the exact same properties of this, except that all four edges are now equal. All right, let's keep going. These two, I'm sure you've heard of already. They are a rectangle and a square. So a rectangle has two pairs of equal opposite sides. So here's one pair of equal sides. So those two are equal. That's one pair. And here's another pair. So these two are equal. But the other attribute of rectangles is that there must be four right angles. So 1, 2, 3, and 4. That is a rectangle. And I'm sure we all know what a square is. We just have four equal sides and four right angles. Now, notice how I've included four right angles. Because if we said that a square is just a quadrilateral with four equal edges or sides, that is actually still a rhombus. Because a rhombus has all four edges or four sides are equal, but a square has the special property of four right angles. All right, and now to the last two special quadrilaterals. These are actually just special forms of trapeziums. So trapezium is just so long as we have one pair of parallel edges. These still have that. So here's the pair of parallel edges. Here's the pair of parallel edges. But with an isosceles trapezium, we have one pair of equal opposite sides. So these two sides that are non-parallel, they must be equal. This causes a special angle relationship between these, that these two angles must be equal and these two base angles must also be equal. And the last special quadrilateral is a right trapezium. All a right trapezium is that there has to be two right angles, but the pair of parallel sides is still there. Now, despite all these varying properties of each quadrilateral, there's actually one property that is common to all quadrilaterals. It's that the angles of any quadrilateral, they have to add up to 360 degrees. So if you were to add these four angles, angle A, B, C, and D, they must add up to 360 degrees. Now, these are just the properties that we've gone through. In the next video, we're going to apply this concept along with some of these properties to see the angle sum of quadrilaterals in action. Hope to see you then, and yeah, best of luck.